Okay, in this video, I'm going to walk you through some important considerations for layout for the final project, the clock. Now, this example is for a circular layout, and you can choose rectangular, but as I mentioned before, we have some frames cut out of plexiglass that you can use if you choose this design, but it's up to you. First of all, make sure that you review the PCB layout considerations document before starting. There are a lot of important steps in there. You can mirror parts to place them on the bottom of the board. And the ones that I've selected here are IC1, C1, C3, B1, which is the bridge rectifier, X1, the connector, the switches, and the speaker. And the reason for that is you want access to those, or for example, with the voltage regulator, it gets warm, so we want that kind of on the outside of the board, and the heatsink sticks up a little bit. So to do that, let's say, for example, you wanted to mirror this LED, not that you would, but if you want to flip it to the other side, you simply click on the mirror button here and click on it, and it basically puts the silk screen on the other side of the board, and that's why it's flipped like that, but it also rotates the part. So that's important, I think, because you want to make sure that those parts that are, like, for example, the connector are on the back side and the switches, you wouldn't want them underneath the frame. Now, if your design, if everything is just mounted on the front, that's fine, but that's just a consideration. These small 0.1 microfarad capacitors that are rectangular, you want to put those close to the power pins on the ICs. So the 4543s, the 74138s. It can be either towards pin 7 or pin 16, depending on your preference or where you have space for them. Those basically are used to filter out any noise that could get onto those points. Same thing for the capacitor here with a voltage regulator. You want to make sure those are mounted close to the component. And we'll talk about these ones in a second. So going through the notes here, in this case, what I did is I deleted the previous frame. And so pretend, for example, there's a rectangular frame that would have been deleted. And to add the circular frame, you'd go to Circle and make sure that we're on layer 20, and that's the routing layer. And I'm going to select a circle here, and I'm going to start it at the origin, right there, 0, 0. And I'm going to move it out to, I think it's 5.8 inches, which would be, I think it's 2.9. Does that sound right? 2.8 inches. I think that, no, there it is. Anyway, the diameter isn't super critical. Yeah, it was 5.8. Sorry. And that will make it so that it'll fit behind the frame if you choose that frame. I'm just going to double check that real quick and make sure that's right. Oh, no, it is a little bit smaller. My bad. Sorry. So it's actually, yeah, 2.8 inches. So that'd give you a 5.6 inch diameter circle. So you want to make sure that the displays are centered. I leave a little bit of a gap between them, and you can change the grid. If you click up in this window, grid, and change it to 0.025. And I move them away a little bit from each other, and that's just to make sure there's no interference. It'd be pretty bad if you couldn't plug your displays in because they're bumping into each other. I think, though, however, if you did move them right next to each other, there wouldn't be a clearance problem, but that's up to you. Make sure, yeah, we want to add 4 0.150 inch holes. There are 4 of them here, 2 inches from the center. And to do that, we click on the hole command here, which is here. And then you're going to come up here and select 0.150, hit enter, and then that'll give you a good sized mounting hole. So I'm spacing those again at 2 inches from the center. Let's stop there. Okay, and then the crystal, if you're doing the version with the microcontroller, the individual chip, the 328, you want to mount the crystal and these 2 capacitors close to pins 9 and 10. That's because that's a high frequency part of the circuit. You don't want to put those in some other location on the board. Yeah, so here's where I listed the 5.6 inches. I'm just going through these notes here. Make sure LED 12 is at the top. Now, don't try to do this array. If you're doing this pattern, there's a way that Eagle can use a program, user language program, and that's in the next video, to arrange these in an array. But make sure that LED 12 is on the top. Otherwise, you're going to have to modify your code, or your clock is not going to show the correct time. So it starts at 12 and goes in a counterclockwise rotation. Now, for these mounting holes, because the standoffs can be metal, we want to make sure that no traces are going close to where that screw head would go. I've had some disastrous results, for example, where I had a net that was going really close to a screw head, and the screw actually shorted it out. So what you can do is go to the circle command here, select T-restrict layer, which is 41, click on it, and you can drag a circle, and then you can also add the same thing for B-restrict. And what that does is that will create a keep out area, so when it's routing the traces will not go into that zone. Now, I also recommend doing the same thing. For example, if you're putting the name for your project here, you can also draw a rectangle here in the T-restrict. Okay, and if you click and drag, you don't have to click and drag, you click and move this over here, what that will do is prevent any traces from going over that text. You don't need to do that for every single component on the board. That'd be pretty tedious, but that makes it a little bit more legible. Now, one other T-restrict area that's important is that our voltage regulator, the 7805, which you'll notice is mounted on the bottom because the text is flipped, we are going to mount a heat sink on that. That will help keep the heat away from the component. And so what we want to do is make sure that where that heat sink, it's aluminum, and where it's mounted, that it won't have any traces underneath it that could short out. So in this case, I'm going to click on a rectangle, go to B restrict because it's on the bottom, and click and create an outline there around the component. Okay, let's see what else we had. I think that's pretty much it. Oh, as I mentioned, for the Nano version, if you are in 117, you won't be using IC2 or the crystal or these capacitors or either of these power bypass capacitors. Those are all installed on the Nano board. But you want to make sure that you could mount that on the back. It might be a little bit easier because you have to make sure that you can plug or unplug it to program it fairly easily. Probably you could do all the programming without any problem if it's mounted on the top, but that's up to you. And you change that by mirroring it. Okay, if you have any questions on this, please feel free to email me. I'm happy to go over any questions on this. But again, please go through this document. It's kind of long. You only need to look at the first page, but there are just some considerations for how you would actually do the routing for it in the layout.